Hi, I'm Medrano, and welcome to Crash Course AP Statistics. Over the last 5 months, we've studied everything stats, from measures of central tendency and spreads to probability, proportions, and p-values. But what happens when you take those concepts and throw them into the real world? What happens when those concepts become a reality? And what happens when you are able to turn the time it takes someone to sort a deck of cards into your very own stats problem? Understanding the basis of our project requires taking a step back and evaluating the real world, or at least the stereotypes we've established. Teenagers are characterized by, for lack of a better word, obsession with the digital world. Consumed by the excitement of the biggest video games or constant updates of social media, modern-day generations often turn a blind eye to what our parents would have considered fun. This includes anything from picking up a book to playing a board game, or what you might have guessed, picking up a deck of cards. Because of this generational drift in interest with the entertainment of tangible cards, we put the RHS community to the test. Adults and students alike were handed a deck of 52 cards and asked to sort them according to number, piles of 1s, 2s, 3s, and so on. While most use this task as an opportunity to beat a friend or impress those around them, we thought it served as an interesting way to test if adults' experience with cards could outweigh that of students and result in quicker sorting times. We go to Isaiah with a look at how we were able to test this hypothesis.
First, we had to establish how we would obtain our sample. If we were to conduct a simple random sample, we would have to have compiled a list of all the faculty members on campus and assign a number to each individual. Then we would use a random number generator to produce 30 random numbers and sample each faculty member assigned to those respective values. Likewise for students, but because a simple random sample would have been beyond our realm of ability, we turned to convenient sample, reaching out to students and teachers that were in our classes or on prep. Due to the lack of randomization, we recognize that our results may not be indicative of the entire population. And at the same time, we had to recognize that our methods in conducting this project presented some bias. The voluntary response bias in the context of our task would occur during our sampling. Some students and teachers refused to take part in our project, while those who were in a more competitive setting were more inclined to do so. So we found that teachers were oftentimes motivated by being faster than their students or even other teachers. Likewise for students. Response bias in regards to our project could result from the way we explained our task and how our subjects would perceive them. Based on their understanding of the task, some people would have made it more difficult for themselves to sort the cards, resulting in a slower time. Now let's go to Ashton with the results.
First, let's take a look at each of our groups separately. For adults, we had a distribution with a skew right. All times fell within 43.9 and 103.87. As you can see, there's a gap between times of 85.52 and 103.87 seconds. That time of 103.8 seconds was also calculated to be an outlier, with an interquartile range of 17.88 seconds. The middle 50% of all adult times fell between 50.26 and 70.14 seconds. For students, all 30 times fell within 38.27 and 108.91. The distribution of students' times were fairly symmetric, with an average of 62.23 seconds and standard deviation of 13.88 seconds. The slowest time of 108.91 seconds is also an outlier. Now that we've looked at the distributions on their own, let's compare the two. As we mentioned earlier, adults' distribution was skewed right, whereas students' times were fairly symmetric. The variability of the adults' card sorting times is smaller than the variability of the times of the students, which means the adults' times are more consistent and therefore more reliable in relation to the population. Both groups have outliers, but even the adults' outlier is faster than the students. The median time of adults is faster than that of students as well. Now, after all this analysis, we still have not actually tested our hypothesis. As a quick recap, our null hypothesis is that there is no difference between the means of sorting times between adults and students, while our alternative hypothesis is that there is a difference, and in fact, adult times are quicker than students. We go to Greg with the test and interval results.
In order to identify whether or not our sample results are statistically significant or not, we're going to use the two-sample t-test and interval. Since our data is not a random sample, we should be wary of our results as it may not be representative of our population. We will go ahead and assume independence since 30 adults and 30 students are less than 10% of their respective populations, and a t-model is appropriate because our sample sizes of 30 fulfill the central limit theorem. Now that we've established our conditions, let's move on to the actual test. Using a 5% significance level, we can go ahead and run our test. Again, our alternative hypothesis, or what we are testing for, is that the adult times are quicker than student times. First, we find the standard error using this formula. and then using the formula for t, our data results in a t-score of negative 1.1436. After we run our calculations, we result in a p-value of 12.88%, which is much larger than our significance level of 5%. Due to our p-value being larger than our significance level, we do not have evidence that the difference in the true means of time it takes for students to sort a deck of cards differs from the time it takes adults to sort a deck of cards. Another way to test our hypothesis is through a t-interval at 95% confidence. Using the same conditions from the previous test, we can find the standard error and then use the confidence interval formula for a two-sample t-interval that you see on screen, which produces an interval of negative 11.25 to 3.262 seconds. Therefore, we can be 95% confident that the difference in the true means of time it takes students and teachers to sort a deck of cards will fall between negative 11.25 and 3.262 seconds. Since 0 falls within our interval, we have evidence that there is no difference between the true means and time it takes students and adults to sort a deck of cards. Since we failed to reject our null hypothesis that the average times to sort cards will be the same among adults and students, that means that there is a possibility that we made a type 2 error. In the context of our project, the presence of a type 2 error would mean that we actually did have evidence that there was a difference despite concluding that there was none. If we wanted to decrease the possibility of a type 2 error, we would increase our sample size for both groups. Back to you, Cam.
To conclude this project, using the data we've collected, we found that there does not seem to be a difference in the time it takes adults and students to sort a deck of cards by number. Now, of course, we were only able to obtain the results from students and adults around us, so our results cannot be generalized to the entire population. If we were to change our methods in the future, we would aim to establish an official explanation for our subjects so that every person has the exact same set of information before beginning the task. If this project were to be replicated in the future, we suggest that surveyors use a larger sample of students and adults for more accurate results. Thanks for watching.